introduced as Azmi S. Aboulhod. Mr. Azmi leads EMergy Consultancy with a specialization in energy and sustainability in the built environment. With around 3 decades of experience, he focuses on energy optimization, the design of special solutions in built environment industry, and environmental services. He is certified as energy manager, measurement and verification professional, building commissioning professional. Additionally, he holds ASHRAE certifications in building energy assessments, HVAC design, and building commissioning. Azmi is an active ASHRAE member and participates in various operational organizations. Today, Mr. Azmi, we talk on enhancing indoor air quality and thermal comfort. So, without any further delay, let's welcome Mr. Azmi.
Thank you very much for this introduction, and thank you for having me here. As Vivek said, I will talk today about enhanced indoor air quality and thermal comfort. So let's start. I will go through different statements which might be thought about as facts in the industry while they are all myths. So let's go through them one after the other, and we will explain certain basics related to indoor air quality and thermal comfort that we need all to be aware of. Indoor air quality is not a proxy of thermal comfort. The sensors in our body that are dealing with air and its quality are different than the sensors which deal with internal heat and external thermal environment. Air quality is related to air cleaning systems, to contaminants and contaminant sources such as outdoor air, ventilation, such as moisture, biological growth, and so on. Indoor air quality and thermal comfort are 2 out of 6 indoor environmental quality parameters. The remaining 4 parameters are sound, light, odor, vibration, plus indoor air quality and thermal comfort. In terms of standards, for example, we have standards related to indoor air quality, and we have other set of standards related to thermal comfort. For example, in ASHRAE, we have standard 55, which is dealing with thermal comfort. And in this standard, it clearly says that this standard does not address such non-thermal environmental factors. It is only for thermal factors. Non-thermal factors as air quality, acoustics, illumination, or other physical, chemical, or biological space contaminants that may affect comfort or health. Standard 62.2 or 62.1, for example, in ASHRAE deals with air quality. And in this standard, standard 62.2, for example, it clearly says this standard considers chemical, physical, and biological contaminants that can affect air quality. Thermal comfort requirements are not included in this standard. So there are 2 different terms that we need really to differentiate. In the industry, usually they are used interchangeably. However, it is better to make this line and differentiate between these 2 different terms. And in buildings, it is important also to have 2 different systems. One system separate, handling or dealing with indoor air quality, and another system dealing with thermal comfort. And these systems are controlled independently to achieve the optimal results. There are many studies discussing the effect of indoor environmental quality and how the impact of indoor environmental on asthma, on sick building syndrome, on productivity, and so on. So these studies illustrate to us that there is lots of money involved with indoor environmental quality. Having a balancing point might not be achievable because we need to focus and concentrate on achieving the indoor environmental quality, indoor air quality, indoor thermal comfort, and so on, regardless of the energy optimization in buildings, regardless of energy efficiency. This doesn't mean that we don't have to have an eye on energy efficiency. We do, but we don't have to do it on the account of indoor environmental quality. Why is this? Value of health and productivity of building occupants can be more than an order of magnitude greater than the energy they use. the annual energy in typical buildings, the annual energy costs between, let's say, around 200 dirhams or 200 dirhams per square meter. However, the annual functional costs of people is around 25,000 dirhams per square meter. Sorry, I didn't convert this to rupees. If we assume that the people cost, salaries, and so on in a building is 100 rupees, let's say, then the energy cost is only 1. And this means if we do something, anything, to sacrifice the indoor environment and lose productivity, just 1% of productivity. If we lose 1% of productivity so that we improve the energy efficiency, this is the same amount, 1% productivity is the same amount as the whole energy use of the building. So if someone concerned is to save money, then he's not really achieving much or achieving anything at all when he saves energy on the account of indoor environmental quality. We have to find ways of reducing the energy cost without sacrificing productivity. And there are ways to increase the efficiency, to improve the energy cost, to reduce it, I mean, without sacrificing the IEQ, because mainly the building we built are really for people and they are not really for saving energy. And there are many case studies that highlight this, this important fact. For example, in a call center, the filters in a call center were changed, were replaced with clean filters. And in this study, they discovered that by changing these filters and improving, of course, the air quality in the room, the talk time in the call center of the people, of the employees, has increased by 10%. In another study, the classroom temperatures were reduced by 1 degree Celsius, dry bulb temperature. And when they did, performance of the class has improved by 4%. In a third study, ventilation air was supplied at a rate of 10 liters per second per student. And when this was implemented, the performance of the students has improved by 14%. Do you know what does it mean? It means that if the student go for 12 years to the school, now with this improvement of 14%, they can go only for 11 years. So we will reduce 1 year. This is a huge money behind it, a huge deal of money that we have when we really take care of indoor environmental quality. Food and water quality are more important than air quality. This is again a myth. Why? We usually intake 1 kilogram of food every day, and we intake 2 kilograms of liquid. However, we inhale 15 kilograms of air every day, and that's why air quality is an important factor, similar to food and liquid. In many industrialized countries, up to 50% of school children suffer from allergy and asthma, and this figure has doubled during the last 20 years. 50% of students in developed countries suffering from asthma and allergy. In offices, another example, up to 60% of occupants suffer from sick building syndromes, such as headache, fatigue, and so on. In developing countries, every day 5,000 people die, according to the World Health Organization, from indoor pollution. These are huge numbers that we need to keep in our mind when we think about the indoor environmental quality. The minimum requirements set in the building codes and regulations, unfortunately, they have in practice become the maximum. They have become the targeted. And this is one of the major misconceptions in the industry. We need to understand the standards. We need to understand the regulations carefully in order to be able to implement them in our designs. And I will give an example. The ventilation rates set in ASHRAE standard 62.1, for example, these ventilation rates are meant for adapted people to bio-effluents. So the ventilation rates are suitable for those. However, in European standards, the ventilation rates are usually meant for non-adapted people, which means they are higher. We have higher ventilation rates when we follow European standards. So when we want to design for a meeting room, for example, when all people enter the meeting room at the same time, it is okay to design based on ASHRAE standard, based on adapted people, to have lower ventilation rates. Why? All people will enter into the meeting room at the same time, so they will get used to the environment together. However, when you want to design for a department store, for an outlet, where somebody will come inside, grab something and go, it is not okay to tell him wait for 15 minutes until you become adapted and then you will be okay with the environment. You should design based on non-adapted people. You should increase the ventilation rate so that people will feel okay when they enter the department store. So this is how we need really to deal with the regulations and standard in a way that we understand the background, we know how to implement them in the benefit of enhanced indoor quality. Using dry bulb thermostats to represent thermal comfort and to control the system based on this dry bulb temperature is like judging a book by its cover. In 2017, for example, the University of Texas conducted a research project. In this research project, more than 5,500 research papers dealing with controls were reviewed. And the conclusion was that building control research papers do not contain thermal comfort related keywords. Imagine an entire library of documents spanning years of research exploring energy flows through buildings, where in these papers, thermal comfort is barely a consideration. And this explains one of the several conclusions from another study in 2019 of office workers, where occupants generally were dissatisfied with building automation, and they prefer manual controls. So we have a problem with the building automation, and we need really to make sure that this automation is related to the indoor environment. And this cannot be achieved by having a thermostat, a simple thermostat on the wall to measure the temperature. Because if you rely on the dry bulb only, on the thermostat, you will end up with this, what we call it, the thermostat war. So in terms of indoor air quality and thermal comfort, we need to study various factors. We need to study dry bulb temperature. We need to study humidity, airspeed, radiant temperature, draft, temperature variations, floor surface temperature, and so on. So we need to study all of these factors to be able to achieve indoor thermal comfort or indoor air quality. And to design for all of these factors, load calculations, cooling load calculations, heating load calculations are not sufficient. The HVAC design by itself is not thermal comfort design. We need to keep this in mind when we do design for buildings, and how we can explore this and what we can do. Maybe we can take it forward during the panel discussion of talks. And that's it from my end. Thank you.
Thank you, Mr. Azmi, for talking about enhancing indoor air quality and thermal comfort.